Good morning. Today we are going to a new subject, which is solving a second order differential equation with variable coefficients. So we are in 4.7. So we are dealing with second order differential equations with variable coefficients. So the equation has the form a of t y double prime plus b of t y prime plus c of t y equal function of t. Now, just to remind you that we already studied equations of the form. So we had the constant coefficient case, already done. It was when you have something like this, a y double prime plus b y prime plus c y equal function of t. And we discussed the case when a, b, and c are constants. So when they are constants, then we know the way how to solve this second order differential equation. The way was changing the equation first, the solution, so general solution is of the form y equal y homogeneous plus y particular. With y homogeneous, how we get y homogeneous? Y homogeneous, how you get? You change the equation, which is a y double prime plus b y prime plus c y equal 0. You solve this by changing it using the assumed solution e power rt. So plugging in this and y prime, of course, it will be r-e-r-t, and y double prime is r squared e-r-t. Then you change this equation to the form ar squared plus br plus c equals 0. And there was some cases here, cases when you get two distinct solutions for this algebraic equation, when you have r1 not equal to r2 real solutions, then you're gonna have r equal r1 and and r equal r2, and for the first one you get y1, which is e power r1t, and from the second root for the equation you get y2, which is e r2t. Now from these two you can build up now your homogeneous. Y homogeneous will be C1 E R1T plus C2 E R2T. Good. Now there is a case 2. Case 2, we said if we have one root only, and you know in this case you're going to have r, and from r you get y equal, I call it y1 e r t, and to get y2, you know the story, you multiply by t and e r t, and from this you build up your homogeneous solution, yh equal to c1 e r t plus c2 t e r t. Good. Now there is a case 3. Case 3, let me write case 3 somewhere here. Here is case 3. Let me show you case 3 now. Case 3, if we have complex roots, so you have here r equal to alpha plus minus beta I. Then your solution, you know the story, y1 will be e power alpha t, and then cosine beta t, and y2 will be e alpha t sine beta t, and then from this you can build up your homogeneous solution to be c1 e alpha t cosine beta t, and plus c2 e alpha t sine beta t. Now we are not in this case, now we are studying, so this if you have constant coefficients, and for y particular, I'm gonna just remind you about y particular. There was 2 ways to find y particular. So how about y particular? In y particular, there is 2 methods. You look at your f of t. If it is nice, then you go with indeterminate coefficients. And if otherwise, if not, you go with variational of parameter. Variational of parameters method, which says this one, we know that how to assume your y particular solution if it is sine, cosine, or exponential or polynomial. But here in variational of parameter, it says y particular is just v1, y1 plus v2, y2, and there is a formula for v1, you know the formula, and there is a formula for v2, and I will not write the formula now because I'm gonna use it later in this section. Okay, so let me now start with the new section. So in this new section, it says that let me write again. If you have ay double prime plus b y prime plus cy equal f of t, so this is done. Now we are going to a new case when you have a times t squared y double prime plus b times t y prime plus cy equal f of t. Now look, what is the difference now? The difference is we have a t here, t squared here, and t here. So here the coefficient of y double prime is not a constant anymore because we have the independent variable squared here and the independent variable power 1 here and no independent variable here. This equation, I will call it Cauchy-Euler differential equation of second order. But there is one thing here. If f of t is completely 0, then it is homogeneous, then you get homogeneous. And if f of t is not 0, then you get non-homogeneous. So non-homogeneous, so we can call it homogeneous Cauchy-Euler differential equation here, non-homogeneous Cauchy-Euler differential equation. Now how to solve? Again, the method of solving, how to solve this Cauchy-Euler differential equation, how to solve this Cauchy-Euler differential equation. Here is the way. It is always the same way. So you have y equal y homogeneous plus y particular. Now, how to calculate y homogeneous? Let me show you how to calculate y homogeneous. In y homogeneous, you go with a t squared plus y double prime plus bt y prime plus cy equals 0. Now you need to again change this to algebraic equation, but in this case you assume that your solution has the form y equal to now t power r. Yeah, if the independent variable is x, it will be x power r. If the independent variable, for example, if you change to any other independent variable, then it will be independent variable power r. Now, if you do this, what you're gonna have to do y prime first. You get, let me write here, then y prime will be r t r minus 1. And then y double prime will be just r times r minus 1, t power r minus 2. Now, when you plug in the equation, what you're going to have this. You're going to have this. You're going to have a r minus 1, t power r minus 2. And then there's a t squared there. So there is a t squared, sorry, here we don't have plus, it is just a multiplication, a t squared y double prime. So you have here a t squared, a times t squared, and here you're going to have pt, and you're going to have now r t r minus 1, and plus c t power r equal 0. Now just combining this and combining these or multiplying them, then you will have something like this. You will have a r minus 1, and here you have t power r, and then let me just do this, plus brt, and then power r, and here c t power r equal 0. Now what is next? I will divide this equation, I divide over t power r, and I will have the following. I will have a r minus 1, and then here plus br plus c equal 0. So this is the second order algebraic equation that you're going to have. Always you will have the same thing. You need to know the coefficients, which are the constant coefficients without the t. So you need to know your a, you need to know your b, you need to know your c, and then you solve for r, and then you will have some cases. Then you study 3 cases. I'm going to show you what are the cases now. When you solve for r, let me go here. I'm solving for r. Then I may have 3 cases like before. Case 1, if you have r1 not equal r2, 2 distinct real roots. It is like before. You're going to have r equal r1. It will give you y1, which is t power r1. And you have r equal r2, which will give you y2, which is t power r2. And you combine the 2 solutions, and then you get y equal to c1 t power r1 plus c2 t power r2. Then this is my homogeneous solution, because I'm considering here the homogeneous part of Cauchy-Euler equation. Yeah? So we are looking for y homogeneous. Now let me go with the case number 2. Let me show you case number 2. Here is case number 2. Case 2. So So I'm just continuing this here. Sorry, the board is very small. So case number 2. If we have one root, so one root, so we have one r, yeah? Then this r, or if you like, then I'm gonna have y1 to be just t power r. How you gonna get y2? Then you need to multiply with something to get two linearly independent solutions. Now, for now, you take it as granted that you need to multiply by ln t, yeah? Now, what is the reason behind this? I'm gonna show you a formula later telling you what is the function that you're supposed to multiply with, okay? Now, for now, we have these two independent solutions now, and you combine them to get your y equals c1 y1 plus c2 y2, and then you get c1 t power r plus c2 t power r ln of t. Now, case number 3. Here is case number 3. If you get two complex roots, let me just, this is y homogeneous, right? So this is y homogeneous. Let me go with case number 3. Case number 3, if you are getting R to be two complex roots, alpha plus minus beta I. So two, I will not say two, they are two, but they are complex conjugate. So so complex roots, yeah? Then you know what is the story, then we know what is R1 and what is R2, then your Y1 will be just, now not like before, you go with E alpha T. Now you go with T power alpha, and then you get cosine, and here is beta. You will not have T here, you will have ln of T. So here was E alpha T before, now it is T power alpha. Here we had before cosine beta T, now we have cosine beta ln of T. Now Y2, it will be T power alpha, now sine beta ln of T. Again, this is coming from Euler equation for complex numbers that we can write later, or we can discuss later. You can contact me if you have any question about this solution. Now from this one, you can combine the two solutions to get the Y homogeneous. It is C1 T power alpha cosine beta ln of T plus C2 T power alpha sine beta T. Now we are done with the homogeneous solutions. Yeah, I'm done with the homogeneous solutions. Now let's go and tell you about Y particular. So we didn't say till now anything about Y particular, how you're going to get your Y particular. Then for the Y particular, we cannot use, can we use, for example, indeterminate coefficients? Unfortunately, no. Unfortunately, no. No. Can we use variational of constants or parameters? Yes. This one is yes. Okay. Do you still remember what is the formula for this? Then Y particular here, this is for this. Y particular will be V1 Y1 plus V2 Y2. And you know the story, V1 is just minus the integral of y2 f of t over. Now this will be a of t now because it is a function, maybe it is a function of t. It is the whole coefficient for I'm gonna write it a of t because it is not the a, the constant a. It is the whole coefficient of t squared. And here the Wronskian of y2, y1, or y1, y2, doesn't matter. And then here we have the dt. And v2, of course, it will be with positive sign and y1 f of t. And down is the same, a of t, w of y1, y2. And then we have the dt. Good? Now let me solve some questions on this.